You've been working hard to get that Android application done right, and now you want to publish it. Welcome to Android 220. My name is Rene, and I will guide you through the process of getting your application ready to be published on the Google Play Store. We're going to split this into separate parts. There are certain settings that we have to apply directly in Xamarin Studio or in Visual Studio, depending on the IDE that we're using. Next, we'll move on to Google Play. What is it? How does it work? What do we have to prepare there? And finally, we want to see how can we upload the application to the Play Store. Let's start by looking at the options that we can tweak inside Xamarin Studio. There are a couple of release build options that we should tweak and really have to tweak if we want to deliver an app that runs at maximum performance. We find these settings if we open the project options of our Android project and then switch to the Android build tab. I'm going to walk you through the options later directly in Xamarin Studio, but let's start with ProGuard. This is a new Java virtual machine feature in ART and available in Android 5 that will obfuscate and shrink the included Java bytecode. It's going to remove unused methods in the Java libraries that your application depends on. If you have an application that makes use of big libraries like Google Play or other support libraries, it can significantly reduce the resulting file size. Android application files, they contain executable bytecode. The format of these files is the Dalvik executable, or short DEX. This is the compiled code that is actually running the application. The Dalvik executable has some limits. The total number of methods that can be referenced within one single DEX file is 65,536. Now, these days, Android applications, they tend to become bigger and bigger. So more often we start hitting this limit. By enabling multi-DEX, the single DEX file is going to be split into separate files, and that's going to increase the limit from 65,000 to many more references. Then we have a feature here that is only available in enterprise licenses of Xamarin. The Embed Assemblies in Native Code option is going to take the .NET, that means the IL-based assemblies, and wraps them into a native Android library. And this will make them slightly harder to disassemble if people try to deconstruct the app. And I say slightly only because it's a very thin layer of protection. The final option in here that I would like to discuss is the AOT, which means ahead of time compilation option. This is available in business editions of Xamarin. Please be aware that this is currently considered a preview feature. By default, Xamarin.Android uses just-in-time compilation. With this option enabled here, we can pre-compile our code, so we're going to have higher performance, better startup times. However, at the moment this is not compatible with debug mode and it is required to enable the LLVM compiler. Also, you should not confuse this option with the ahead of time compilation that is available on Android directly. With the new ART engine, which is the successor of Dalvik, there's ahead of time compilation taking place directly on the device. But these two options that we have here, they are completely unrelated to each other. The AOT option here in Xamarin Studio is really meant for the managed part of your app, while the AOT option available for ART, this is meant for the Java part of the app. Android devices come in many flavors as it comes to CPUs that are used inside them. For that reason, we have to support different ABIs. ABI stands for Application Binary Interface. This pretty much determines such details as how functions are called and in which binary format the information should be passed from one program component to another. In the case of the operating system, it's necessary to deal with system calls. In order to support different CPU models, we have to include different ABIs. The default here is ARM ABI v7a for release builds. And this setting provides a significantly better performance than the original ARM ABI. If you're planning to target 64-bit ARM platforms, like the Nexus 9, be sure to select ARM64 v8a. If you're planning to deploy to an x86 device, make sure you select x86. If the x86 device uses a 64-bit CPU architecture, then you would also add the x86_64 and so on. To target multiple platforms, you can select more than one architecture. but be aware that this is going to generate a larger APK. There's an option which allows you to control whether you want to create one package for all ABIs or one per selected ABI. Also note that the 64-bit support is not required in order to run your app on a 64-bit hardware. For example, the 64-bit ARM devices, they can run apps configured for ARM ABI v7a. The primary advantage of enabling 64-bit support is to make possible for your app to address more memory. With the release build specific settings in place, we want to move on to the basic settings. Every application must have an application name and a package name. The package name must all be lowercase. There should not be any spaces, no special characters. It is recommended that you use the reverse DNS notation here. So in our example with Xamarin, that would be com.xamarin.application-name. Also be sure to provide an application icon. This is the icon that is going to be used in the settings application on the device. This is not the icon that is going to be shown on the launch screen. The launch screen icon is actually defined inside the main activity in the attribute that we set there. Talking about icons and images. As technology has progressed, manufacturers have brought out hardware with ever-increasing resolutions. We have insanely high pixel densities today. And an increase in pixel density, or dots per inch, that basically means more image information can be displayed in the very same space. To support that, Android defines so-called buckets. The basic bucket, that's MDPI. That means medium pixel density. And then we have high pixel density, HDPI, which is 1.5 times the baseline. XHDPI, 2 times the baseline, and so on. Be sure to provide as many icons as possible. But don't worry if you don't have them all in place. The Android device is going to pick the closest available and is then going to scale it. In the Android application settings, we also find the versioning entry fields. The version number on Android is just an integer. It is never going to be shown to the customer. Now, this is something that you can use as a build number. As a developer, we must always increment the version when submitting updates to the Google Play Store. Otherwise, the Play Store is going to complain that the version already exists. The version name, that's the customer-facing version. It's sometimes also called the marketing version. Could be that we have created internally already 100 builds, but we still want to release our app with version 1.0. The remaining two settings, they deal with the Android versions that we want to support and target. This is actually not such an easy topic. We're going to cover it in the next slides. There are 3 types of API levels that we can configure for an Android app. We have seen 2 of them in the application settings. That's the minimum Android version and the target Android version. So let's discuss these 2 first. The minimum Android version, that defines what is the oldest version. That defines what is the oldest version of Android that our app is going to work with. Now, this really is a promise that we don't use anything that is not available on these older devices. But with the target version, we say this is what it really runs best on. This is what we optimized for. And then we have a third option that is not in the application settings dialog, but we find that in the general tab. In here, we can configure the target framework. The target framework says that's the API level or the SDK that we build our application with. So again, let's recap. Maybe we build our application with 5.1. This is what we have available on our development system. We promise our application runs on 2.3. And we say it runs best on 4.4. Normally, you should always build against the latest SDK. Right. We have seen theory on the slides. Now let's have a look at the application that we're going to submit to the Play Store today. So here we have it. It's the Simpsons Contacts app that some of you might know from other Xamarin University classes. This is the Android version, and we see it works, so it is basically ready to be shipped to the Play Store. Now let me stop debugging here, and we want to configure our release settings. We open the properties of the Android app, and we start with the general here. This is where we select the target framework. We just discussed that. You see that if I open this drop down, I actually have a lot of different SDKs installed on my machine. I'm building this application with the latest installed, which is 6.0. Going down to the Android build, we have General, Linker, and Advanced. Let's go through them. Before we do this, make sure that you have selected the release configuration. This is what we want to use for the build that we put onto the Play Store. In the General tab, the shared mono runtime must be disabled. We cannot assume that every device out there has a mono runtime enabled. If we want to embed assemblies in native code, I can try that here. You see, for me, this pops up a dialog saying it requires me an Enterprise Edition. I don't have that, so I cannot enable this option. We could generate one package per selected ABI. We don't need that here. The application is actually really small. But let's enable the other advanced options here. We can switch on ProGuard if we want to. We want to skip the debugging options. You should never enable instrumentation for your release builds. Let's switch to the Linker tab. In here, nothing has to be done in our case. Switch to Advanced. We want to select the ABIs. And let me go through these. I think we are fine with supporting x86. We don't need a lot of memory, so I don't think there's a great advantage of using the x86 64 or the ARM64 V8A here, so I'm happy with that configuration. Let's switch to the next one. The application name is currently mycontacts.droid. I don't like that. Let's make that something better. So we want to make that Simpson Contacts. And we also want to adjust the package name. Notice that in here we have mixed upper and lower casing. While this works, I don't recommend it. So I want to make all of these lowercase. We specify an icon, that's fine. Our version number is 1. Our version name, this is what we used to go public with, that's 1.0. I'm also happy with that one. Now the minimum Android version. So here we can select what is the minimum operating system version that we support. And honestly, I haven't really tested it, but I presume this is going to work at least on 16, so I'm going to select that one. And for the target version, well, there's nothing special here. We typically leave this to whatever we have set as the target framework version. So that means for us that's 6.0 or API level 23. We don't need any permissions, so we're fine with that. Now, let's click OK. And maybe we want to run this app once with the release configuration to see if it works. The app built and deployed correctly. So here it is. This is now in release mode. Of course, you should always test that on a physical device. So this is very important if you want to go to the App Store, but we're skipping this here now. Now let's switch back to the slides and continue over there. The Google Play Store is where we're going to deploy to today. So again, like before, we're going to do a walkthrough here on the slides, and then I'll switch over and show you the real thing in the browser. We want to introduce the developer console. That's where we manage our applications. The developer console really is just a website that is available at play.google.com/apps/publish. Before we can use it, we actually have to register for a publisher account. Registration is $25. That's a one-time fee. We got to enter basic information about our identity. We got to accept the licensing agreement, and then we are done. If we want to sell applications there, we have to sign up for the Google Payment Merchant account. Payments will be issued in the local currency via bank transfer. For every app that we have in the Google Play Store, we can define the price. And actually, we can define the price per country. Every month, the pays are transferred to our bank account. And just like with Windows and with Apple, there's a 70-30 split. That means Google gets 30%, and we get 70%. And what's left, our taxes, that's what we can happily spend. You can always go ahead and configure the merchant account by navigating to Reports, Financial Reports, Setup. Here I'm in the browser and I'm logged in with a Google account that I have not registered for development yet. So just so you see the screen here, we have signed in with our Google account. And I now have to accept the developer agreement. I gotta read through this here and we continue to payment. Next thing is to pay the registration fee. So you gotta have a credit card there, otherwise you cannot continue. Once you have agreed to the terms, you buy this registration, and that's really all, and your account is set up. I'm going to switch accounts now because I don't want to pay twice, and then we'll continue. This is what the developer console looks like if you have logged in with an account that is properly registered. And this account that I have here, it actually already has an app on the Play Store. So here you get an overview of all the apps, their pricing, how many installations, and so on. We're going to come back to this later when we are ready to publish our contacts application. We have already set up all the release options in our Xamarin Studio solution, and we have registered for the developer console. The next step is to create an application package. This is what we are going to submit to the store. The package that we're going to submit has got an extension that is APK. That really means Android package. You can also think of it as the application package. In there, we find everything that our application needs. This is the manage.NET code in IL version, the runtime, the framework assemblies. It also contains the DEX files that are necessary for execution, all the resources, including the images, and so on. An APK can be downloaded and installed directly onto devices. We're going to talk about this later. It's very easy to create an APK directly from within Xamarin Studio. We just enter the build menu, and in there's a menu option that's called Archive for Publishing. And this will then allow you to either save the APK locally, so you can upload it manually, or it can also directly distribute to the Google Play Store. If you prefer to use Visual Studio, you can also build the Android app in there. In the Tools menu, under the Android sub-entry, you find the Publish Android app. However, this is just the manual option. So from there, you have then to go ahead and manually upload the created APK. The next step that is necessary is a signing process. Just like on iOS, an application must be signed, but where it is very difficult on iOS to deal with all the different certificates and the provisioning profiles, the device IDs, the app IDs, and so on, it's fairly trivial on Android. When we create an Android package, it must be signed with a unique key that represents the publisher. And the publisher, well, that's you. And unlike Apple, Android does not generate or store these keys directly. Instead, they provide a command line tool that allows us to create the keys locally, and the developer tools then use the generated certificates to sign the application. And all applications must be signed with a cryptographic key that expires after October the 22nd of the year 2033. Don't ask me why it's specifically this date. And Xamarin Studio will generate all of this for you, or you can use the command line to do it manually. And the key store is then the place where this signing certificate is finally stored. For debug builds versus release builds, there are two key stores. So you might wonder now, why have you never had to deal with the key store when deploying your application to the test devices? Well, that's because Xamarin Studio is creating a default key store on your behalf. It is important to keep the key store safe. This is what identifies you as the publisher. If you want to ever update your application on the Google Play Store, you will have to use the same key store. Otherwise, the application is considered as a new app and you won't be able to update. We're back in Xamarin Studio and we want to try this Archive for Publishing process. I enter the Build menu and select Archive for Publishing. It's building the release build of our Contacts app. Let me get that out of the way. And we see it shows a nice view here of all the apps that we have archived so far. So you notice here we have an iOS app and here's the Android version. So from here on, we can always see what version of the app was archived, when was it built. If we're happy with that build, let's go ahead and sign and distribute it. The wizard that pops up gives me a chance to either save the resulting package to disk or to upload it to Google Play. If I want to upload to the Google Play account, I have to provide the required information for Xamarin Studio to log in. If we save to disk, we have to create an Android signing identity. We don't have one here at the moment, so let's create a new key. This will be our Simpsons key. Let's put some password in there. The validity of 30 years, that makes sure that it expires after that date. Now I've got to provide some information about us here. And we confirm. I want to select this just created signing identity and continue the wizard. It tells us that all the required information has been collected and the app is now ready for publishing. So let's do that. We're going to publish this APK directly to disk. It wants me to select a folder to store that to. Now it asks me for the password of the certificate that I've just created. And that's it. We now click the button to reveal the package in the Finder. And from there we can take it and upload it to the developer console. We're now ready to submit our application. We want to see what else is there left to set up and understand the publishing process a bit. And we're going to see two different ways of actually installing the APK onto a device. The steps that are used to publish an Android app, that's always the same, basically regardless of the distribution method that we use. First, we got to compile for release. We just did that. We create our certificate. We sign the APK, and then we can go ahead and publish it wherever we want. That can be through the Google Play Store, but you can also publish through the Amazon store. If you want, you can even go ahead and distribute the APK via email, upload it to Dropbox, put it on your server for download. If you have an Android device and you navigate to an APK file with the built-in browser, it's actually going to install the APK. Android is very flexible as it comes to distributing. We want to discuss both sideloading and store publishing. Sideloading means putting the APK directly onto a device, no matter where it comes from. The only thing that is necessary here is that the device actually has to allow unknown sources. By default, an Android device only allows installation from the Google Play Store or the store that it is associated with. You can go into the Settings app and check the Security tab, and in there you find unknown sources. Go ahead and check that, and from there on you can simply navigate to an APK file, download and install it. Also, installation via ADB is possible. Let me quickly show you what I think is a pretty elegant way to get an APK onto a device. So here we are in the folder in Finder where the APK is located. I got a little utility here that opens me a terminal window right in this location. I'll make that a bit smaller. Now in here we can see that's where the APK file is located. Now if I want to get that on any device, I can simply start up a web server in this directory. And it's pretty easy on OS X. You can use Python for then and fire up the simple HTTP server on port 8080 for instance. Now it starts serving this folder here. Let's quickly switch over to the Android. Here I open the browser, and I can now navigate to the HTTP URL of my machine. So that's 59, and I gotta go to port 8080. And what we see here, gotta make that a bit bigger. That's the folder listing of the folder that I'm serving from my Mac. So I can now simply tap onto the APK. It's going to start the download. And once it's been downloaded, I can simply open it. And it asks me whether I want to install that application. With this, you can upload your application to any folder on the local network or put it on a server and just send out an IP address to your testers, for instance, and they can grab it directly and load it onto their devices. The second option, of course, is store publishing. The biggest players here, that's Google Play and Amazon. Amazon is necessary if you want to target the Fire devices. We're going to focus on the Google Play Store today. Now, this is what we saw before when I showed you in the browser the developer console. Here is where we set up our application. We get an overview of all the apps that we have, and we can add a new one. Once we click that button, we can either go ahead and directly upload the APK that we've just generated, or we can first decide to prepare our store listing. Please notice that already here you can select multiple languages. It's important to localize your listing. We got to fill in all the necessary application information. This is the title of the app, a very meaningful description. Of course, we want to give it a price. We want to provide screenshots for different resolutions, for tablets, for phones. One word about pricing here. If you have an application that you want to sell for a certain price, and then you want to give it away for free for some time, there is no way to go back to a priced application. So better think twice before you give it away for free. Just like Apple with their test flight program, Android supports beta testing. Actually, on Android, it is split between alpha and beta testing. There's no real technical difference between alpha and beta testing. The only thing that it allows you to do is to configure different applications for different user groups. Your testers are managed with Google Groups. It's actually quite tedious to set those up. But then you can provide one build that is going to be the next one after the one that is currently in production. So that would be beta. And you can create some fancy upcoming version, maybe testing things that won't make it into the final product. That would be your alpha project. Like on iOS, there is also a review process for the Google Play Store. It's just not so strict. The reviews mainly look for violations of the publisher-developer program, so you better read through these policies. At any time, you can check the publishing status directly in the developer console. Now that we heard the theory, let's try it out. We're at the developer console and we want to add a new application here. Our default language is going to be English, so that would be the Simpson Contacts app. I want to start by uploading our APK directly. It's saving. We drop it in here. It should start uploading. Our app has been uploaded and we can see immediately that it's going to run on 8011 supported Android variations. Our version is 1.0. That's what it configured in Xamarin Studio. We can here make use of a translation service if we want to. It's very important that you localize your apps, but don't just let it go through Google Translator or something. I would now go ahead and configure our beta users. We can either set up a closed beta testing. This means we gotta invite users directly, or we can use a public beta test. This is where the app is really available already. All you have to do is you must know the URL, so anybody can participate there. The same goes for alpha testing. Like I said, no technical difference here, just another version of your app. Let's move on to our store listing. We have to provide a title, a meaningful description, a full description, and I'm not going to fill all these things in here. And finally, we must provide a lot of graphical assets. One for the phone, one for tablet. If we support Android TV, we got to provide that too. We need a couple of graphics. You see the ones marked with a star, those are mandatory. So I want to go with a high-res icon here, some feature graphic, gives an overview of our app, and we have to categorize our app. So this one is going to be an application, not a game. Our category, well, that's obviously business, right? It's Simpsons. We have to fill in a content rating, so that's suitable for everyone. There's also a new content rating, which requires us to fill in a little questionnaire. So we have that over here. We can continue here. Let's put that here. And we select our app category. So that would be some utility or productivity. And no, we have no violent material in here. No sexual materials. No offensive language. Well, Homer's got a beer sometimes, but I don't think that's considered an illegal drug. And so on. So hopefully we can answer all of these with no here. I'm going to save the questionnaire. Based on the questionnaire, it's going to calculate the rating now. Here we see now how it's rated in different countries. We want to apply that rating to our app. I go back. Next thing to fill in here is a website, an email address to contact us. We can provide a privacy policy if we want to, and so on. What's left now is to set up our pricing and distribution model. So we move on to the next tab here. We can say whether this is going to be paid or free. We can specify default price here. We can also select in which countries is it available. Well, let's select all the countries. And Google has a feature here that allows you to automatically convert the default price to all other countries. And over time, you might have to make adjustments there because sometimes tax rates change in different countries. So you gotta have an eye on that. You can also set the price manually for different countries here. When we're done and we have provided all the necessary information, we're currently missing the images here, we could save and actually publish the application. Once we press the publish button, it means the app is going to go into review, and then it's going to take, well, I'd say approximately 48 hours, so nothing compared to the 10 days that it sometimes takes over on iOS, and your app is ready. You get an URL, it's going to be listed on the Google Play Store. Well, it's ready for distribution. I hope you enjoyed watching this recording, and you're now ready to publish your app, either via Sideloading or through Google Play Store. If you have any questions, feel free to contact me. My email address is rene@xamarin.com.